So then in the last class we were writing ERC 20 contracts. So I think I'm just going to open my, I don't know if I should go back to the slides or let me go back to the slides and check what is there. So let me slide show this. Yeah, so yes, we're writing a trait. Yeah, let's open our VS Code. If you have your laptop, you can. How many of us were able to like? Oh no, I don't think any of you would have because we didn't go that far. We didn't. I don't think we went that far in the last class when we writing our contract. So share my screen again. So yes, back to our. I don't know. I'm very sure you can hear me now. So back to our VS Code. We had a few things doing there. So these are these are the functions here. You have the approve function, transfer. There's an ERC20, yeah. And I explained what an ERC20 is, your normal tokens and how it works. That of course you hold the tokens, but in the technical aspects or real life aspects, how it is coded, is it token that actually holds your address and tells how much you hold and the rest. So I don't know. This this should change color. Should change color. Yeah. Anyways, let's just continue like that. So let's first change this from hello sadness to your sequence. So we are going to use this. We need this for storing. What's wrong with augments? We need it for storing values into the storage. Then, of course, we need this now. This is to expose our entry points. These are the entry points that we need here. We want people to call this from outside. So we expose it with this. I'm sure we did this last week. This is for storage, and this macro here tells the compiler that okay, this is a contract, a Starknet contract. So what else am I missing? Yeah. So now let's implement this interface. It's normal, like just copy and paste. Control C, Control V here. Um, Yeah, when you're copying and pasting, don't forget your key point. You have to run with so that this should match this. But at any point, yeah, I'm teaching and you are not getting one or two things, just call my attention. I'll go back to it. So this, let's remove this. Let's call it ERC 20. Then this hi hello Starknet will be this. So we are going to copy this, then we're going to paste it like that there. So this implements this. And if this implements this, then we will have to use all the functions there in the interface. So balance now, balance is it's one thing they call when you're doing your contract, you have to do an architecture of how the contract may be. So that you don't have to start deleting, removing, adding, that kind of stuff. So what do? We have balance here, but balance of what exactly? What we need to store is both the balance. There are so many balances now we need to store. Yeah, we're going to go this in real life because I've forgotten most of the things we're going to import, but it's okay to forget, and I'll show you how to remember them. Maybe you go back to a past project or you go to the Cairo book or Starknet, by example, you see some examples there on how to use some of their variables. But using your Sudoku, you know, okay, there's a balance here. This balance is for what exactly? This balance just increases. It does absolutely nothing, but you want to increase the balance here. But how do we know that this balance now belongs to what user? How we are going to use that? We are going to use a map. Yeah, so this balance is now, you can use a map for it. A map of contract address and U256. So now we are saying for each user of the address, we are going to store their balance here. So it's really fair. Yeah. So now for now, we are going to store only balances. We'll come back to whatever they need for approve. And yeah, they also have one more thing, allowance. So we also can put allowances here. This is for the approve function. So you want to know, no. This is, you want to know what, you have done map. So this is the key and this is the value. So for example, now I want to check the balance of a user, the user of a contract address. Then when we get the caller address, the person that calls the function, we do the storage dot balances dot entry. You're going to read this address. Then you're going to write the value here or read the value. So this is the key and this is the value. And to make everything more optimized in allowances, we can make the key distinct by now the person that approves. Normally, this approve now gives permission from the caller of this function to the address here. We can call this address the target address. So somebody calls this function and say, okay, approve this person here now. Approve this person. I approve this person to spend this amount on my behalf. Some of you will be reasoning why somebody want to spend something on your behalf, but that's how it works here. If you're in a contract and the contract is spending your money, you have to authorize it to spend your money. So let's say the contract now wants to deduct some amount of money and pay another person. It has to take your permission first. So that's what it means by spending on your behalf. So when I call this function now, the caller now should be this contract address. Then who we are going to approve should also be this contract address and the amount you are approving. So that if we read both the caller and the target address, who we seem to approve. If you read it and this value now, in map, the default values in Cairo for you to receive, the default value is 0. So if you read a key that does not exist, it returns the default value, which is 0. So let's say this was a bool. If you read a key they have not written to, maybe I'll be writing maybe contract address of OXO, OX1, blah, 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 and the rest. And now there is one contract address of OX4. There you have not written again. You have not written here. If you read the value of that OX4, this value will be false. So I think that's that. Now this allowances now, you are going to I hope you're all following. Yeah, so this allowances now is a map. So once we take the caller address and the target address, if you read it, if it's not existent, meaning that okay, this thing now, why we use a tuple here is because we want to make it to be distinct. Yeah. So if it's not existent, maybe you are this person now didn't approve this person, and we read it from this map, from these allowances now. This should return 0, meaning basically that this person approved this person 0 amount. So now when we want to check it, we check that if transfer from, or if transfer from an address to an address, then the caller now must check if it has been approved by the person that owns the money. You get to that. So what else again do we have? We have mint. Mint deals with balances. So we're going to initialize some balances, but for now, let's do something like this. You have to put a constructor. Normally, when we are using yes, this constructor now, you should know that it runs only once when deploying your contract. It's a function that runs only once. Are you with me? Yes, you are. It's a function that runs only once when deploying your contract. So when you initialize the variables and you deploy. And when you're writing your constructor now, you might want to initialize some variables. Maybe for some reason you want to set the balance of something to be 0. But okay, let's put in a parameter of maybe when our address, yes, sorry, this is all this contract address. When our contract address, yeah. Then what else again? So we need only the owner for now. Then you should know that yes, because normally the owner now, since you're the owner, you want to mint it some amount of money. So there are different ways of minting. Sometimes you want to make that okay, only the owner can call this function. So we might want to write the owner here. You're wondering why there will be an owner of a contract. Yes. There are some functions that you don't, because the contract is open to the public. Anybody, anywhere can call any function. And like I said earlier on, you don't want people to abuse the mint function because you might want, or you might have in your tokenomics that, okay, yeah, you're just going to deliver maybe this amount of initial supply for now till whenever, then later on. But in the end, you might have a fixed total supply. But you are going, not that you are going to deploy the contract with all the tokens already in supply. No, you might want to just deploy and set a fixed to set a fixed initial supply, at least to some extent. Then maybe later on you can increase it. So you don't want people to be calling the mint and whatever. So you might want to block it for just the owner. So you leave the owner here. So in this kind of case now, you say self dot owner dot write. Like you write the owner. So that in this means now you check the color if the color is really the owner. Yeah, at some point I'm going to debug this. I don't know why it's not highlighting. Wait, let me check. What else? You get back to that. So now we have the approved transfer from balance of means. So I think we should start implementing one of them. But like I said, we have, okay, let's say we need, of course, every token has their total supply. We have a decimal name and symbol, yeah. So I'm going to initialize them here. So let's say no, the token is my token. And the symbol will be maybe NTK. All right, no, this should be good. Yeah, so this is something you initialize the name of it so that if you want to read, you'll say, okay, this is, yeah, you want to read the name of your token, the decimal, the name and symbol. You're going to add extra functions here now that we're going to use to read it. I'm burning now. Burning is to burn to make the token disappear from circulation. So we won't be using that for now. Yeah, so anyways, we have initialized our token here. And we might want to be generous to mint this owner some amount of token. So let's say the total supply is self dot total supply. Let's make the total supply a constant. Say so say is one no say it's 1 million billion trillion 1 trillion coins here. Then I'm going to write no, we don't want to see now. We want to mint this, we want to mint the owner some amount of tokens. You understand? So just the thing is about this is just the number. Just yeah, those numbers you get. They're just numbers. So now is that maybe want to mint the like somebody asked about the meaning of mint that time. And this is what the meaning is. I'm just going to add one or two things. I'm going to write self dot balances dot write. Maybe we're going to write the owner. No, sorry, this is balances dot entry. There are many ways to write it actually. So to write this variable here.
Don't see your
Come on,
screen.
come on, I am not
What?
seeing your screen. I'm not seeing your screen.
Wow. Yeah, thank you very much for notifying me. This laptop, no, this. So now, here, I believe you can see it now. So what we want to do is to modify this variable, these balances now for the owner. So we're going to write some the entry of owner dot write. Let's say total supply. Yes, we want to give the owner all the supply. I think. Yeah. Or let's call it initial supply. I'm going to go to this function now. And I'm going to implement them, and I'll explain why we implemented them that way. So yes, we have the approve. Now let's go to this transfer function first. So transfer, let's say the basic thing now is the caller address. So let's get the caller. We're going to use this get caller address for getting the caller. Then we have to check the balance because you can't tell me that if somebody has $20, you will now transfer $30. You're a magician, I understand. But now we have to just make sure to check that, okay, the color now, the balance now is sufficient to make this transaction. So you're going to check it here. So this is just let the balance, you get balances of this color. The entry, that is the map. For each map has an entry. And the entry takes in the value of the key. So now this is the color address is the contract address, and the balance cells or balances takes in an entry of the key, which is the color, and read. Read, I want to read the value and check if the value is greater than or equals to this amount. If not, if it's your assert, use assert here. Assert if balance is this, if this function is true. If it returns false, it throws error and reverts the whole operation. So yeah. So now what I'm going to do is just manipulation of um, manipulation of numbers. You remove from this and you add to this. It's just that easy. Yeah, so you're going to deduct if the balance of the color of that function is actually greater than or equal to that amount, we're going to deduct that amount from the balance of the color, then add that amount to the balance of the receiver. So this is the receiver here. We're going to transfer to this address. So yeah, so that is it. So yes, is self dot balances dot this. Yeah, normally we throw an event here, but I think maybe later, maybe next week or maybe Friday, we'll talk about events if actually is there to be talked about. So this is how your transfer function basically looks like. You minus from the balance of, you update the balance of the color by minusing it, then you update the balance of the lucky guy that the caller wants to send some amount to. So that is your transfer. Now let's talk about transfer from. You might be wondering what difference between transfer and transfer from. Transfer is a direct call from the caller. Now this is the direct call. Now the caller wants to transfer from his own account to another person's account. What you transfer from now is the caller wants to transfer not from his own account, wants to transfer on behalf of this person to this guy here. And now I cannot, maybe I want to transfer some amount of money, say from goodness to, I don't know how many people are here. Okay, from goodness to now to Basil. Then I will just transfer all his or her money to Basil. Like, how does that work? I have to take like permission from goodness. I say, I want to transfer your money. I want to transfer this amount of money, this thing. Please give me permission to do so. You get. Goodness now say, all right, go ahead. It's not because of the security of the contract now. I cannot just go to somebody's account and transfer from that person to that person. And this can be used as maybe as a broker. Most times, me now, I'm the contract. And maybe two of you are the users. Yes. So maybe this person made a deal. Maybe it's a borrowing and lending contract. And now goodness has to approve me now to take control of his or her funds and use it to make one or two transactions. So you're going to approve me, okay, let's say okay, from goodness now, say okay, let's approve this contract. I have $200. Let's approve this contract to use just 100 and make it 100 to do the transactions on my behalf. And now is that most of the now you must work with in real life scenarios. You must work with contracts that are audited. Audited in the sense that it has passed all security checks. There are companies and workers that do these audits. They make sure that there are no flaws or bugs in the contracts. Yeah, some contracts are buggy that they might eat up a user's money. So before you operate on any platform or DApp or contract, before you sign the transaction and say, I approve this contract to take charge of this amount of funds, you must make sure that you trust that contract. So that's all about security. Now, this is just about transfer from, how it works and why there has to be a transfer from. So, like we did with his brother above, we get the color. Let's color equals to get color address. When we get this color, we get the allowance to check how much actually did this from give me exactly. I'm the caller. The caller now, maybe I'm a contract that calls this function now. As I send this amount of tokens from to. Now this contract I have to check now if me now that I'm calling the contract now, if this person now that I want to help use our money, if he or she has actually given me permission to use, this is me here, giving me permission to use that amount. This amount now, like I said earlier on, witness might make me okay, take charge of just $100 out of 200. So if I want to transfer from on behalf of goodness, the amount must not be greater than 100. So that's why I'm going to get this allowance now. I want to get this allowance. We check if this amount is greater than or if this amount is less than or equals to the allowance. If not, we are going to try error. We are going to use the same assert. Then once we do so, we do this kind of operation here, and we are going to reduce the allowance because deduct this amount from the allowance and write back the same allowance. So, yep, right. Like I said, we have to check if this allowance is greater than or equals to this amount. Yeah, so that is it. We call insufficient allowance. Then self to allowances dot entry. We are going to deduct this amount from the allowance to tell the contract that okay, yes, if goodness gave me $100 and I took 50 from it, the remaining allowance should be 50. So we're going to do self dot transfer. Although that in a real life scenario, they will tell you that okay, you cannot call this function like this. Perhaps it takes gas or something. Or it does, you have to watch out for re-entrance. Re-entrance is one of security risks that most people do, unless although that they have I think there's a package on Open Zeppelin, a tool, not actually to the dependency that takes control of re-entrance. Re-entrance is when somebody calls a function that and the function is written in such a way that the function enters more than once, or the storage is written more than once. For example, now look at how I call transfer here. So I call the transfer now, and this transfer now also calls transfer from. Maybe it is one or two checks. If this thing called transfer from, I'm giving it as an example. So once this transfer from calls, once somebody from the outside world calls this transfer from, yeah, enters here now and calls this transfer. Transfer now enters here now. And for some reason it passes that check. And there's another self dot transfer from here. It enters here the second time. That's what we call reentrance. Re-enters that same function that they called from the beginning. And most times it escalates to security issue. That kind of thing now, the contract now might perform something that it was never meant to perform. Like say transferring twice. That kind of stuff. So yeah, part of the security risk. So what that the entrance guard now opening the link doors is that once you add a guard here and add one more guard here. So if you call this transfer now, it ends here. It will never get back here again. In the sense that the transfer now performs a check. And the check passes by some means and it calls this function again. It did not pass this guard here. Yeah, so that is how the reentrancy guard works. So I'm not saying that this thing can call transfer from like secretly. It will be explicitly written here by a dev. Maybe he might just one or two checks. He might not mean it. This function, this contract is just way too simple. That you might not even know. You might be asking why will somebody call the same function here. Your function can be very, very, very complex. It be very different files, different lines, and you might not know when you call one function and that function calls another function. And now that function now calls back that same function that was initially called. So it enters that function twice. So you might get to that. But for this kind of simple contract now, you don't need all those things. So this is itself the transfer. You can write it like this. You can write also this. Depends on how you want to write it. But when you're writing it with this, you must put the ref of contract state. Sorry, this is contract state, not the contract state. So, yep. Yeah, so I'm trying to debug, trying to understand why sometimes that's how Scout does. It just misbehaves. Now I'm just trying to understand why it's not understand why it's not like this. And most times it misbehaves, yes. So I don't even know. Cannot find cairo LS on this machine. What a pain. What do you mean cannot find cairo LS on this machine? So now let's leave this for another class. So I'm just going to do one or two explanations. Um, so I think that's how transfer form works. In a real life scenario, we are going to import this. I think this comes from Starknet. Starknet. So what else? Yeah. Then we have done the transfer and transfer form. So let's go to the balance of. I want to read the balance of an address. Yeah. This one does not require any check because anybody should be able to read your balance. So we just Yep. So if the address does not exist, if this address does not exist, like I said, it will return the default value of a U256, which is 0. Yeah. So if somebody does not hold this token now, if somebody does not hold this token contract will not have the person's address in the balances part of the storage. And when it reaches the address, the value returns 0. And of course, don't forget to forget your semicolon. When you're returning a value, you don't put semicolon there unless you want to use the return keyword. Yes, now let's go to the means. Means you just manipulate the value of the balance of the address there. But you want to get the color. And you want to restrict this main function, like I said. So you can say let color equals to that. Yeah, now we want to check if the color is the owner. Check the balance of the address, that is the target, the person you want to mean to. Then we are going to increment the total supply. So this is absolutely. We get the color first. We assert the color is the owner that we have deployed in the constructor when we deploy the contract. If not, the person is not unauthorized. Then we check if the balances, we check the balances of the target address, that is this address here. Once it passes this check here. So we put the address now, we increment it by the amount. So this is us writing to the address. But to get the formal balance now, in which you want to increment, you read from that address, from that balance, the address. Then you add the amount. Then of course the total supply. I don't know, total supply. So that change it to initial supply. In its initial supply now, so you have to change the initial supply. You have to increment it too. You increment it by writing to it. Well, before you write, you have to read the previous balance, then add the amount. So what else have we not done? Approve, yeah, approve. We're going to work with the color here. Although I don't think there are any checks. We're going to check. We're just going to use the color address, the person that called this function. And we're going to increment the allowance. This is not, like I said, you have to read the previous amount before writing it. So it's not, yeah, we have to check the balance. No, we don't have to check the balance first. Just based on how you implement your own, yeah, to 20. Most times, or sometimes, people like to check the balance. You cannot approve somebody to spend on your behalf if you don't even have that money in the first place. So if you have balance of 0 or 20, you cannot approve more than that $20 that you have. But sometimes you might want to approve before having the money. Yeah, you don't have the money yet. So like that. And of course, when there is this transfer from now, is this transfer. And this transfer now was and this transfer also checks if the balance of whoever it is, if the balance is adequate. So, so yeah, that's it. approve, we get the caller address. We might skip, we're going to skip the allowance. Sorry, we're going to skip if the caller now, the balance now, he has that amount that he wants to approve. We're going to skip that of the caller. Then what's the amount here now? We can't just write it. What if this same address now, for example, here's an example that we want to implement an allowance. Maybe previously I told the contract that okay, out of $200, use $100. Then for instance, maybe the contract now is maybe working is maybe a trade contract, and is giving you funds. You say you want to give it more funds now, let it use and trade. So you might want to approve some amount. And you cannot please just rewrite the whole amount in such a way that if you had approved 100 before, and now you now do another approval transaction, and you write 50 here, it just changes whatever is here to 50. Which I don't see very lazy. So here one more thing, if you're making your own ARC20 token, you might make it custom, not additional to subtractions. You get. So there's no like I know that there's a standard way for you to follow, but you must almost always know that you can alter some things, change some things, add new functions that are not in the standard ERC20 functions, just for it to perform as you want it to be. So now for my implementation or Web's implementation, we're not checking the core group. Now I'm going to check, I'm going to read previous amount, self dots, allowances. Yeah, I'm going to add this previous amount to the new amount. So let's say I make a mistake and call maybe approve a contract, maybe 1,000 now, and I made mistake and wrote, or I know that okay, not that I made mistake. I just rewrite. There are two implementations we get. This one, the one I implemented is in a situation whereby we approve a contract and we want to increase the amount. Yeah. But then, what if you approve a contract now and you want to reduce the amount? Maybe I don't trust this contract again. Then you want to now say, okay, let me approve this contract, zero amount of tokens. But we're not reached to that yet. It's just up for contemplation. And of course, feel free to give your thoughts. Well, if you read the previous balance and increases it, that's that. Normally, you try and error, but it won't. So this reads this alters the allowance. And we check transfer form, it only reads what? Oh, sorry, it reads yes, it reads first and checks if. So now let's say approve now from address 0 to address. Let's say the caller is address 0, then this is 1. It writes the key now is 0 and 1 of tuple. It reads it, then writes it. So whenever contract now 0, this is 0 and this should be 1. The entry of caller and address you must understand when you're using your approve now. You must know what comes first. So, for example, I don't know if you can see hear me, but for I don't know, I'm not sure if there are questions. My voice is echoing. What was this? Is my voice still echoing? My voice is echoing, please. Don't forget to please just tell me. I don't know if it's because of the space. Yeah, so now this is how it works. If you write, if you do a mistake, because now we're not using values here, we're just using variables. So if you do a mistake and write 0, maybe for example now, 0, 1, 0, 1, and you read 1, 0, it will give you a different value. And now you start looking for where your bug is coming from. So now, for example, now you say, okay, now let's get through this now together. We have, okay, yeah, let's get through this together. Now we have the color. The color is, now this is who we want to approve here. Address. Address comes second here. And the color, the person that you want to transfer on behalf of, comes first. So this means that the person you want to transfer on behalf for should come first. Now, if you go back to this transfer function now, this transfer from, you will notice that you are transferring from this to this. So we are transferring on behalf. The person we are transferring from on behalf of this person now comes first. Yes. Approve. The color comes first. So I think it's correct. It's correct. Then this over here, the color should come second. Yes, it's correct. So you must know sometimes you might do a mistake and put color here and from here. So that's what you should be checking when using a tuple or when you are even working with tuples in general. That's what you should be checking. So what next? I think that's all for this contract. Let's go back to the slides and see if you have anything to say there. As you can see now, we have used the traits for standards like ERC20. We use the trait, we defined the name, symbol, and transfer. The storage, you have done the storage to constructor, yes. Initializes the token, sets name, symbol, initial supply. The implementation, the actual logic of all functions in the trait. Yeah, there's a way to deploy. But before we can deploy, we must be able to build. So there's something I want to check. Yeah, I am writing and deploying an ERC20 contract. So you should be able to deploy this and test it out. But first, let's add the other functions that returns owner, initial supply, decimals, name and symbol. Yep, so that should be all. What else again? Um, let's debug why this is not resolving. I don't know. I feel I should start my vscode. So yeah, so the next thing we're going to do. I don't know if you guys are hearing me. The next thing we're going to do now, after typing our contract, is we are going to build it. We are going to build with Scab. No, what? Terminal. I'm going to use Scab build. Building our contract. So um account address. Let me go to my account on yeah, so I know that the past or in week one they told you to install some wallet extensions. I know that some people had some issues with installing them. So now for when you're using Ank to deploy your contracts, it's far easier than your command line. Once you're using Ank, you have to use get your Sepolia address and the private key. I don't know if you tell me check out how to so for me to operate to my private entities, I have to stop sharing my screen at the moment. So for those that don't know how to operate agents or how to find your private key, you launch your extension. That is for agent users. I don't know of Bravo, so your agent users. So you click here. If it's on mainnet, you have to click here, then switch to Sepolia. So when you click there, the first thing you're going to do is actually to copy this address. That will be the one in the one here. Then your private key, you also click here. Sorry, once you click here, you click on these three dots, then export private key. You put in your password, then you copy your private key. Once you copy it, you come here and put in here. Your RPC is always sealed, so don't bother about it. So where should I go? So you want to use the owner. Let's see this. Yeah. The root. Sorry, just so any questions? Maybe on Friday we'll deploy the contract and interact with it. For now, you can just go and practice what you have seen. So if you have any questions on today's class, feel free to notify. If there are no questions, then we can call it a day. Good night and see you on Friday. Thank you.